Speaking of being impressed, here's our next guest. So, Norbert, you're part of the Science Fair Foundation in British Columbia again, right?
Yeah, yeah,
And fantastic. And you're 20 years old and you're from Surrey.
yeah, yeah.
Hey,
So your product is called the mechanical jaw thrust device.
Yes.
That's exciting already. I'm thinking that has something to do with the medical field.
Yeah, yeah. So I actually thought of it while I was shadowing a bronchoscopy procedure, which is where a radiologist takes a biopsy from a patient's lung to see whether or not that mass that they're looking at is cancer. And yeah, I actually had you guys will see my inspiration was from watching a nurse perform the jaw thrust when I thought that it might free up nurses to allow their expertise in a better way if there were a device that were to do a jaw thrust.
We're excited to hear about this.
Sorry, it's taking so long. Okay, I think it's good now. All right, I will share my screen and then I'll get ready to present. Okay, please let me know when you guys, okay.
we see it. It's perfect.
Okay, great. Okay. Hello, my name is Norbert Banyi, and I'm a 20-year-old UBC student from Surrey, BC, Canada. My innovation is a mechanical jaw thrust device which forces open the airways of sedated patients and is a device that is useful in environments such as operating rooms where patients are receiving bronchoscopies. So, as I've mentioned earlier, last summer I had the opportunity to gain firsthand clinical experience with bronchoscopy procedures for which a nurse or respiratory therapist must manually hold a patient's jaw in jaw thrust position for about 45 minutes straight, about 5 times a day. I realized that a jaw thrust device can standardize the jaw thrust procedure to improve procedural efficiency, patient safety, as well as reduce hospital cost. When I designed this device, I studied the motion of a jaw thrust performed by medical personnel so that my device can offer the same tilt, forward push, and lift of the jaw as a human would by having these 2 degrees of rotation that you can see here and here. So, as well as having or performing the procedure as close to as a person as possible, it has a few key features. So the first feature is that this device is equipped with a one-sided adjustment that allows it to be just adjusted fast from the side, as you can see closing in onto the patient's head so that it can wrap around the jaw. Now, this facilitates use by a single operator, being that it's one-sided. Furthermore, if you release the button, which you would be pressing to do a fast adjustment, then you can turn this knob and perform a more fine adjustment so that the device can be snug against the person's jaw. Next, it has a one-directional ratchet mechanism, and it's a modular plastic design, so it's quite easily manufactured, as well as because it's plastic, this can actually be more versatile. For example, if we were to make the device all plastic, it can go in an MRI, or in other cases where a nurse, like in an MRI, a nurse can't be holding the jaw in jaw thrust position, whereas this device may be able to. Furthermore, this ratchet mechanism allows the operator to lift the jaw, lift the device's arms along with the patient's jaw, and it will just hold the jaw there. Next, it's designed to have simple assembly and disassembly, which makes manufacturing efficient and allows for easy sanitization, as well as allows for any more designs to modify the device, as well as put attachments in case there's any other procedures in which it can be helpful for. Finally, the manufacturing cost, because it's an important component of making a medical device, is about $40 for a metal and plastic part assuming, or in the case where we take the metal parts and order them with standard off-the-shelf parts, whereas a plastic design, completely plastic, will be about $30, assuming that the molds and stuff like that are made. Finally, there are further applications of this device, and this device overall will help standardize procedures involving the jaw thrust, and this will relieve nurses or respiratory therapists to focus their invaluable help in better ways in the operating room. Furthermore, an excellent application of this device includes a cervical collar attachment that slides in place, as you can see here, so that emergency responders may be able to stabilize the neck of a patient with cervical spine injury while performing the jaw thrust to ensure that their airways are open. Because in many cases, emergency responders don't actually try to perform the jaw thrust to make sure that the patient is breathing because they're afraid of secondary damage in the spine. So this can actually save human lives. And lastly, although I was not able to test it on people due to coronavirus and other factors such as that, I've actually went through and done finite element analysis, and you can see here, this is the finite element analysis done on the jaw support, and there are no parts of it where it's taking too much load so that I can no longer handle. And I've gone through each part, and yeah, it seems to be able to take the force that might be exerted if a patient's head were to be in the device. And yeah, thank you so much for listening to my presentation.
This is amazing. And I am a medical expert because I have watched all seasons of Grey's Anatomy. So I have watched every jaw thrust and intubation and car accident that there has been. And since I've watched them at least 3 times all the way through, I've seen this happen. So what is your next step? Like, the person that you watched do the jaw thrust, have you told people? Who knows about this?
Yeah, so I've spoken to the radiologists that have observed the jaw thrust, as well as a few nurses and respiratory therapists, and they all said to me, there was one thing I kind of noticed them all say was, I've been wondering why something like this hasn't been implemented yet. And that's the first thing I was thinking when I designed the device. And nurses actually whom I've talked to said that it might be helpful in environments where there isn't enough medical personnel, such as like an overloaded hospital, and in a scenario where a rapid intubation might be needed, or an intubation might be needed that would normally be best done by 2 individuals, could be done more easily with 1 individual.
So obviously I see them, like you said, on ambulances. I see them in the field in military scenarios. Would this be an FDA regulated thing? Because there are some, I mean, I'm just trying to think, it's medical and, one wrong turn and they could be paralyzed. Have you researched any of that?
Yeah. So I haven't looked too much at FDA, although that would be part of my next steps. I have looked at Health Canada because I've first been thinking of implementing it in Canada. And this device, because it's non-invasive, and it's not going to be interacting with any kinds of wounds or anything like that. All of the skin that's going to be touching will be intact. It's actually a Class 1 medical device, which is much easier to implement than other devices. And one safety feature which I've thought of in designing the device includes, if you guys can see here, these parts actually come out, and if there were to be anything wrong, for example, in the operating room during bronchoscopies, the most frequent issues are if the bronchoscopy device actually makes a little cut in the person's lung, they might have to do an operation. Or if the patient aspirates some food that comes from their stomach, then there might have to be some emergency protocols. But in that case, these 2 arms just rip off, and it's as if the patient were to be in a head, like on a pillow. So it's got that safety feature.
is this your chosen field? Like you're shadowing radiologists. So are you looking to be in the medical field?
Yeah, so I'm actually studying for the MCAT right now, but currently I'm studying computer science, genetics, and statistics. But as I said, I am working in hospitals such as BC Cancer, and I did work with St. Paul's as well. So this is in Vancouver. And yeah, eventually I do hope to become a physician.
So I noticed you had a patent pending.
Yeah.
Okay.
So I've filed a provisional patent, and that's pretty much it.
Well, this is not your normal invention. This is one that you've done a lot of research on and can truly save lives. I've watched my Grey's Anatomy, and I know that there's sometimes when they cannot be intubated well, like they have to go straight for a trach. And this being so, I don't know what the word is, but it's going to happen to every person's going to get the same treatment on this. So if you have someone that's trying to intubate that's not really good at it, this is going to sort of generalize all of that. So they're getting the same treatment.
Yeah, exactly what you said. So an important thing is to standardize medical procedures, and there have been there have been studies with many medical procedures such as CPR, where a standardized procedure will save lives. It makes things more efficient, more cost effective, and just quite frankly more optimized.
Well, thank you so much, Norbert, for being here. That was very interesting. Are you going to call it the Norbert, or have a name for it already?
No, I was thinking of calling it like the Aaron. So it kind of sounds like Aaron, but then it's like a play on words, like air goes in. But nothing too solidified yet.
Well, hopefully we won't need that. But if we do, I hope that your invention is already out there.
Thank you very much.
Very impressive. Very impressive.
Can you unshare your screen for us, Norbert?
Yeah.
Thank you so much.
Yeah, thank you for having me.